Hello, today we are going to discuss analyzing of constraint plans. So, what are the objectives of this lesson? After completing this lesson, you should be able to identify the seeded exceptions in a constraint plan, use calculated order attributes to understand plan output, and recalculate plan output after making changes. The first section we are going over is the seeded exception messages. So what are these messages? Demands at risk, late supplies, rescheduled supplies, supplies to be canceled, overloaded capacities, and usage of alternates and substitutes. First, what are the benefits of these seeded messages? Basically, by using these seeded exception messages, you can easily manage your plan by displaying only those items and orders that require your attention. Further, you can narrow your search using other criteria such as resource or supplier. Also, you can drill down on an exception to get more detailed information about the nature of the exception. First, we review the demand at risk exceptions. The demand at risk due to insufficient lead time is generated for any supply n-pegged to the demand when the suggested order date is earlier than the planned start date, and rescheduled days is negative, and firm status is not firm. The demand at risk due to a resource capacity shortage is generated for the resource capacity measures of any resource used in making any supply that is n-pegged to the demand when the resource availability is less than the resource requirements. The final demand at risk exception is the demand at risk due to a supplier capacity shortage. It is generated for the supplier capacity measures of any item that is n-pegged to the demand when the supplier capacity availability is less than the supplier capacity required. Next, we'll examine the late supply exceptions. The late supply pegged to forecast exception is generated for the days late demand order attribute when the days late is positive, which means the forecast could be at risk due to the late supply. There is a similar exception generated for late supplies that are pegged to sales orders. The late supply pegged to sales order exception is generated for the days late demand order attribute when the days late is positive, which means the sales could be at risk due to the late supply. The orders with insufficient lead time is generated for the order attributes when the suggested order date is earlier than the planned start date, and the rescheduled days is negative, and the firm status is not firm. The orders to be rescheduled in exception is generated when the supply is needed earlier than scheduled in order for the end demand to be met on time. The rescheduled days calculated by planning is less than 0, indicating the number of days the supply should be moved in. The orders to be rescheduled out exception is generated when the supply is needed later than currently scheduled. In this case, the rescheduled days calculated by planning is greater than 0, indicating the number of days the supply should be moved out. The orders to be canceled exception is generated for existing supplies that have no demand. In this case, planning updates the order status type to canceled. Next, we look at the overloaded messages. The resource overloaded exception is generated for the resource utilization percentage measure when the resource utilization percentage is greater than 100%. The supplier capacity overloaded is generated for supplier capacity utilization percentage measure when the supplier capacity utilization percentage is greater than 100%. Now let's look at the exception messages when alternates are used. The order source from alternate facility is generated when the value of the alternate facility used order attribute is equal to true, which means the order is sourced from an alternate facility. The order sourced from alternate supplier is generated when the value of the alternate supplier used order attribute is equal to true, which means the order is sourced from an alternate supplier. The planned order uses alternate work definition is generated when the value of the alternate work definition used order attribute is equal to true, which means the order has used an alternate work definition. The plan order uses alternate resource is generated when the value of the alternate resource used order attribute is equal to true, which means the order has used an alternate resource. The plan order uses substitute component is generated when the value of the substitute component used order attribute is equal to true, which means the order has used a substitute component. This exception is generated when the component item has substitute defined in the item structure and the primary item has some lead time, supplier capacity, and/or resource capacity constraints. Another scenario when this exception is generated is if the create supply plan option is set to no for the primary component and there is enough on hand of the substitute component. On the other hand, this exception should not be generated when there is no lead time and capacity constraint for the primary and if all the demands can be met on time. Or there is enough on hand of the substitute item, but there are no lead time or capacity constraints for the primary. In this case, on hand of the substitute will be pegged to excess. The only thing I want to say about the displaying and managing exception is this. It uses the same task regardless of whether the exception is relevant to an unconstrained or constrained plant. The next section we are going over is the use calculated order attributes. For constraint plan, new attributes are calculated and available in the supplies and demands UI or resource requirements UI to aid plan explainability. Here, two diagnostic attributes are listed with their applicability and description. One is the consumption start date, and the other one is material available date. Two other diagnostic attributes are shown here. One is the latest start date, and the other one is contributes to overload. The list of attributes continues here. These are contributes to demand lateness, shared supply, uses order modifier, and peg to firm. Here are some details that show how you can diagnose a plan output. For example, if the need by date is less than earliest start date, that means that the supply is on the critical path of demands that are within lead time. In this case, the supply will be planned to start on its earliest start date so as to minimize demand lateness. And some more details related to your diagnosing plan outputs are provided here. For example, if the contributes to overload is yes for some supplies in the pegging tree of an end demand, then the planner can filter the list of supplies in the pegging tree in the supplies and demands page to only show those supplies that have contributes to overload as yes. This helps the planner quickly understand the items that need action in order to make the plan feasible. The next section we are going over is the recalculate plan output. First of all, you can simulate supply chain changes in a constraint plan by recalculating a subset of the plan output in response to a user-initiated change to key plan inputs such as supply and demand quantities and dates. The other way is simulating the impact of plan changes by running the plan without a fresh snapshot. Here we have listed what recalculate action does or does not, and how it is different from the run plan action. Here we are comparing recalculate with replan in terms of which one we need to use with respect to different kind of changes. For example, you can see what is going to change in the plan results using the recalculate function if you change demand or supply quantities, as well as changing resource or supplier capacities. On the other hand, there are some changes that the recalculate function does not respond to, and in those cases, you need to use the run plan function. For example, changing item structure, item supplier, or work definition attributes. Here we also have the comparison of recalculate versus replan for some other type of changes. Here in this example, we see how the recalculate process affects the plan with respect to a demand date or quantity change. For example, it updates the projected available balance of the item and also updates some of the order attributes of the demand, such as the suggested due date and days late. Now we are looking at how the recalculate process affects the plan when user changes a supply due date or a quantity for a planned order or existing supply. Similar to what I said before, the recalculate function updates the projected available balance of the item and the items for which this supply generates dependent demands. In addition, the recalculate function updates some of the order attributes of the demands pegged to this supply, such as days late, quantity by due date, and material available date. Here we are looking at how the recalculate process affects the plan when user adds a new supply or change the process of an existing plan order. For example, in this case, the recalculate function updates the projected available balance of the item and the items for which this supply generates dependent demands. In addition, it calculates the key order attributes for the new supply that is added. Let me point out what it doesn't do. It does not generate any new supplies in response to new or increased quantities of the dependent demands resulting from this supply change. Here we are looking at how the recalculate process affects the plan when user chooses an alternate resource for a resource requirement. As you see, if user chooses an alternate resource for a resource requirement, by recalculation, the original resource requirement is updated with the new resource. In addition, the resource hours for the newly selected resource are calculated based on work definition specifications. Please note that a simplifying assumption is made that both the old and the new source have approximately the same processing rates. Finally, here we are looking at how the recalculate process affects the plan when user chooses a substitute component for a plan order. Basically, what we are saying is this. If user chooses a substitute component for a plan order, by recalculation, the dependent demand for the original component is updated to have a quantity of 0. In addition, a new dependent demand is inserted for the substitute component. Here we have the complete list of planning measures that are recalculated upon a recalculate action. For example, when user chooses a substitute component for a plan order, the supply, demand, and projected available balance measures for the old and the new components are updated. Another example is this. When a user chooses an alternate resource for a resource requirement, the resource-related planning measures, such as resource requirements, resource utilization percentage, are updated for both the old and the new resource. Here we have the complete list of supply attributes that are recalculated upon a recalculate action. For example, some of the supply day attributes that are recalculated, like the suggested dates, such as suggested due date, suggested order date, and suggested dock date. There are also supply quantity attributes that are recalculated, like order quantity and start quantity. Here we are looking at the resource requirement attributes that are recalculated upon a recalculate action, including a start and end dates, resource hours, a scheduled quantity, adjusted resource hours, and a scheduled date. And last but not least, here we are looking at the dependent demand attributes that are recalculated upon a recalculate action. These include order quantity, suggested due date, make or buy, and using assembly. So what you should have learned in this lesson is this. You should be able to explain the types of seeded exception messages and seeded exception set. You should also be able to describe how you can use calculated order attributes to understand plan output and recalculate plan output after updates.